So let's start again with a fair coin. And this time, instead of flipping it 4 times, let's flip it 5 times. So 5 flips. 5 flips of this fair coin. And what I want to think about in this video is the probability of getting exactly 3 heads. And the way I'm going to think about it is, if you have 5 flips, how many different equally likely possibilities are there? So you're going to have the first flip. Let me draw it over here. First flip, and there's 2 possibilities there. It could be heads or tails. Second flip, 2 possibilities there. Third flip, 2 possibilities. Fourth flip, 2 possibilities. Fifth flip, 2 possibilities. So it's 2 times 2 times 2 times 2 times 2. I hope I said that 5 times. So 2, or you could use this 2 to the 5th power, and that is going to be equal to 32 equally likely possibilities. 32. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32 possibilities. And to figure out this probability, we really just have to figure out how many of those possibilities involve getting 3 heads. We could write out all of the 32 possibilities and literally just count the heads. But let's just use that other technique that we just started to explore in that last video. We have 5 flips here. So let me draw the flips. 1, 2, 3, 4, 5. And we want to have exactly 3 heads. And I'm going to call those 3 heads. I'm going to call them, let me do it in pink, heads A, heads B, heads C, just to give them a name. Although what we're going to see later in this video is that we don't want to differentiate between them. To us, it makes no difference if we get this ordering: heads A, heads B, heads C, tails, tails, or if we get this ordering: heads A, heads C, or heads B, tails, tails. We can't count these as 2 different orderings. We can only count this as 1. So what we're going to do is first come up with all of the different orderings if we cared about the difference between A, B, and C. And then we're going to divide by all of the different ways that you can arrange 3 different things. So how many ways can we put A, B, and C into these 5 buckets that we can view as the flips if we cared about A, B, and C? So let's start with A. If we haven't allocated any of these buckets to any of the heads yet, then we could say that A could be in 5 different buckets. So there's 5 possibilities where A could be. So let's just say that this is the one that it goes in, although it could be in any one of these 5. But if this takes up one of the 5, then how many different possibilities can this heads sit in? How many different possibilities are there? Well, then there's only going to be 4 buckets left. So then there's only 4 possibilities. And so if this was where heads A goes, then heads B could be in any of the other 4. If heads A was in this first one, then heads B could have been in any of the 4. I'll just do a particular example. Maybe heads B shows up right there. So once we've taken 2 of the slots, how many spaces do we have for heads C? Well, we only have 3 spaces left then for heads C. And so it could be in any of these 3 spaces. And just to show a particular example, it would look like that. And so if you think of, if you cared about order, how many different ways can you out of 5 different spaces allocate them to 3 different heads? You would say it is 5 times 4 times 3. 5 times 4 is 20 times 3 is equal to 60. So you would say there's 60 different ways to arrange heads A, B, and C in 5 buckets or 5 flips, or if these were people, in 5 chairs. And obviously, there aren't 60 possibilities of getting 3 heads. In fact, there's only 32 equally likely possibilities. And the reason why we got such a big number over here is that we are counting this scenario as being fundamentally different than if this was heads B, heads A, and then heads C over here. And what we need to do is say, well, these aren't different possibilities. We don't have to we don't have to overcount for all of the different ways you arrange this. And so what we need to do is divide this by all of the different ways that you can arrange 3 things. So if I have 3 things, that are in 3 spaces, so here I have a heads in the second flip, third flip, and fifth flip. If I have 3 things in 3 spaces like this, how many ways can I arrange them? And so if I have 3 spaces, how many ways can I arrange an A, B, and C in those 3 spaces? Well, A can go into 3 spaces. It can go into any of the 3. A can go into any of the 3 spaces. Then B would have 2 spaces left once A takes one of them. And then C would have 1 space left once A and B take 2 of them. So there's 3 times 2 times 1 way to arrange 3 different things. So 3 times 2 times 1 is equal to 6. So the number of possibilities of getting 3 heads is actually going to be this 5 times 4 times 3. Let me write this down in another color. So the number of possibilities, let's write pos for short, number of possibilities is equal to this 5 times 4 times 3. 5 times 4 times 4 times 3 times 3 over the number of ways that I can rearrange 3 things, because we don't want to overcount for all of these, viewing this arrangement is fundamentally different than this arrangement. So then we want to divide it by 3 times 2. Divide it by 3. I want to do that same orange color. Dividing it by 3 times 2 times 1. 3 times 2 times 1. And which gives us, in the numerator, 120. 120 divided by 6. So divided by 6. Oh, sorry, that's not. It's 60 divided by 6. This is 60. 5 times 4 times 3 is 60. It gives us 60 divided by 6, which gives us 10 possibilities. 10 possibilities that gives us exactly 3 heads. And that's of 32 equally likely possibilities. So the probability of getting exactly 3 heads, well, you get exactly 3 heads in 10 of the 32 equally likely possibilities. So you have a 5/16 chance of that happening.